Basically, the mean value theorem can work wherever the function is continuous and differentiable. Okay, and technically, it says that it has to be a closed interval of continuity and an open interval of discontinuity. But the big thing you're looking for here is where is this function continuous and differentiable? And if you were to graph any sort of logarithmic function, you should get a shape that looks something like this. Okay, so it has a vertical asymptote, never reaches a certain x-coordinate, and it never actually stops climbing. Its rate of growth keeps going down and down and down, but it never stops climbing. So it's continuous everywhere on this interval. Oh, that's my bad mouth. Everywhere here, it's continuous, right? And it's also differentiable. Differentiability would be a problem like if we had an absolute value function because the derivative at this particular point doesn't exist because the derivative a little bit to the left and a little bit to the right aren't the same. No problems with differentiability or continuity. So the real thing that we need to calculate with this problem is we need to find out where that vertical asymptote is. So we'll set the argument of the logarithm equal to 0. And if you solve that, you get x is equal to 9 over 5. So that's one place we can't have because it's neither continuous nor differentiable at that point. So it's actually any point bigger than x is equal to 9 over 5 where it's continuous. This function, if you were to graph that function, 9 over 5 is the vertical asymptote, and then the graph exists for x values going towards positive infinity. So that's where it's both continuous and differentiable, so therefore that's where the mean value theorem applies. Okay, and that's it. So this one's kind of like finding the domain, isn't it? And if you're wondering why I went to infinity, it's because you can't have a logarithm of a negative number. So I was thinking about all positive values that are possible.